Welcome to this final part of deriving the Broglie equation, which states that wavelength is equal to the Planck's constant over momentum, that is mv. So how did de Broglie come up with this equation? We have to understand that he co-joined two equations. The first equation is E of a photon, energy of a photon, is equal to hc over lambda. This is the first equation that he used, and the second equation that he used is the energy mass equivalence energy theorem, which states that energy is equal to mc squared. So he equated hc over lambda and mc squared. So this is how he came up with the de Broglie equation. So now let's equate these two equations. Let's say E of a photon is equal to energy mass equivalence theorem. So now what we do is we say hc over lambda is equal to mc squared. Now divided by c, both sides divided by c, both sides, we'll see that the c will cancel out, and here will remain with only one c. And so what do we get at the end? We get h over lambda is equal to mc. But now this c is velocity, so instead of writing c, we can write v. So we have h over lambda is equal to mv, because we say the c and v, they're identical. So now let's make lambda subject of the formula. Okay, we'll see that lambda will go on top and mv will come down. So we'll end up with the equation lambda is equal to h over mv. So this is how de Broglie came up with the equation of calculating wavelength of a body mass, where we can clearly see that mv is the momentum of the object that will be moving, where h is the Planck's constant. So this is how he came up with this equation. I hope you liked the video. Yes, you can subscribe to the channel and share it to others.